Hello guys, welcome to Java isEmpty, and let me quickly explain you what are the methods are available in the list interface, and we can discuss it also. Okay, so let's go to the next slide and we can discuss the method of all those list interface. So basically we have already see the add methods, and it is used to insert a element in these collections. So basically we are adding this using this add method for inserting the element in the collections. This is the addAll method. So addAll methods, it will take one collection and it will store inside this. So it is used to insert the specific collection element in the invoking collections. So let me explain you how this method will work. Okay, and let me create one more class called what we can say collection method class I will create. Okay, and we are going to explain the addAll method. So for example, if I want to store, I have two collections. For example, I have two collections. One collection is for example array list. I have a two array list. So one array list a equal to array list a1 equal to new array list, and this is the array list I have, and I will create one more array list. Okay, and I will create one more array list, and this is called a2. I have given in the first array list I will add some value a1 dot add 10. It's having a 10. And in the second array list, so this is the first array list, and this is the second array list. Okay, second array list, and the second array list also having some value, add something like 20 or 30. A2 dot add, and here I will write 30. So we have a two array list, and I want to add this two array list inside the first array list. Okay, so I will write it here also. Add a2 array list into a1. So what we can do is we can write a1 dot addAll. So that time I will not take the help of add, because through the add we can add only one object. But if I add with the addAll with collections, it will go and it will store all those a2 element inside the a1. Okay, let me print. So if you print right now a1, so you can see all those elements from a and b, because we have added a2 inside the a1. Okay, so if you add some collections, then we can go with that one. Okay, you can see here I have printed a1. So a1 means this one, and this array list having only one value, which is 10. But now we are able to see after this one, like addAll. So I have added one more collections here only. Okay, and this is the type of array list. So that time you can go with the addAll. Okay, this is the public remove. So we have already see the remove method. So we can call the remove, and we can pass the index number, or you can pass the value also. And it is used to delete the element from the collection. So we can delete the element from the collection using the remove methods. We have already seen. This is the removeAll method. So it is used to delete all the elements of the specific collection from the invoking collection. So what will happen is, for example, in these collections I will write I will add here this two element also. Okay, and I will give the A2, A1, A1. So I have given here A1, and this is the another array list. Okay, and I want to add this time, so let me comment this one. I don't want to add, I want to remove. So if I call here A1 dot remove, and remove, I have a 4 method. One is based on the index, you can remove one things. Based on the object, means you can pass the value and you can remove those particular object inside the array list. You can call the remove all. So remove all, if you call and if you pass here A2, whatever the element having a A2 like 20 or 30, it will remove from the A1. Okay, let me save it and let me run. So you can see the value of A2 is having a 20 and 30, and A1 also having a 10, 20 and 30. So we are trying to remove from the A1 those collections value which is 20 or 30, and it's removed, you can see. Okay, so this is the use of the method remove. I hope it's clear. Remove if, so it is used to delete all the elements of the collection that satisfy the specific predicate. So you can write any condition, and based on those condition you can remove those particular element also. Okay, if you want to write some condition, so we can write a condition and we can remove it. Okay, so I hope you understood. And this is the retain all. So it is used to delete all the elements of invoking collection except the specific collections. Okay, so retain all, so delete all the elements of the invoking collections. The size, it's return the total numbers of element in the collections. We have already seen in the previous video. We can use the size and we can print like what is the size of the collection right now. We have a clear method, it's remove the total numbers of the element from the collection. So if you call here like after removing the element, and once again you call like A1 dot clear. So clear, CLEAR. So clear, we have a method and we can call the clear. So whatever the element having inside this, it will all removed and it will not print anything. It's a empty arrays, you can say, it will print it. Okay, so this is the use of clear methods. If you go with the boolean contains, so contains also we are using so many times. It is used to search an element. Okay, and contains is very important method while doing a logical coding. Okay, so it's a very important method. So I will explain it shortly how contains method will work. So for example, let me remove all those things. For example, I have one array and I need to check like some of the value is available or inside this or not. So what I can do is I can write one if conditions, and I will write here hey. Otherwise you can write one more things, like you can check A1 dot contains and contains all. So if you use the contains all, you have to pass the collections, but if you use the only contains, so you can pass the object. So I am using the first one, contains. I will check like 10 is available or not inside this. If 10 is available, store this value and it will return one boolean value also. What is the return type? Boolean, contains or not. So based on the contains, I will write conditions contains, and if contains is true, I will say value is available. Otherwise I will write else, and I will say s out value is not available. available. Value is not available. So what is the meaning of this one basically? So if I talk about it, so what I am doing here is I'm taking the one collection which is A1. So A1 is what? It's array list. In this array list having a value called 10, 20 and 30. I'm checking in this array list to 10 is available or not. So yes, if you go and check like okay 10 is available, so it will return true. So it will return true. So it will store here true. If it is store here true, it will print value is available. And let me print also. So comment this line. Okay, and let's see what is the output. So if I run this, you can see value is available. But if I give here something like 100 and 100 is not available in A1. A1 is array list. It's not available, so what will happen? It will print it's not available, value is not available. So this will become false. If A1 dot contains 100, it's not contains. If it is contains, return true. If it is not contains means in the A1 100 is available or not. So in the A1 collection, if you go and check like 100 is not available, only 10, 20, 30 is available. Okay, 100 is not available, so it will return false, and because of this line is false, we are printing the else condition, value is not available. One more thing you can do, instead of writing and creating one more variables here, you can directly write this code inside the if conditions. Okay, so generally we are writing here only. We are writing here only a dot contains 100 or not. If it contains, print value is available. If it is not, value is not available. So that will also work. Okay, so just I am explaining you guys so that you can understood what is the use of contains method. And it's very important, like every time whenever you go to the logical questions, you might be get this chance to use this method. So it's a very useful method, contains method in the collections. Okay, if it is contains 30, it will print value is available. So A1 dot contains, it will remove true, return true if it is value is available. Okay, understood. So this is very important method. It will search the element. So what will happen whenever you given here 10, so this contains method will go and search in the A1 collection like 30 is available or not. So if we search like 30 is available or not, so it will see like okay 30 is available, then it will return true, and then if it is returned true, we can print value is available. Okay, let me go to this collections. Okay, public's boolean containsAll. ContainsAll means like it is used to search the specific collection in the collections. So in the same thing, in the previous example we have talked about. So for example, you have a one more collections. So let me create one more collections here, and this is called A2, and here I will give the value called A1 A2. So control, press the control and click here also, and at the same time you can change both value. Okay, so this is the shortcut. This is the shortcut. Whatever you write here, it will work in the two cursor point. What you have to do is first control, and then whenever you want to change it, you can put that cursor in that places. Okay, for example, I want to change here also. Okay, so I will remove this one. Okay, and here I will write A1. Okay, all those remove. Now I will write something like here. So 3 places are writing A and 1. So it's done. So like that you can write. If I want to write, so first what you have to do is you have to place the cursor and click on that place, whatever the places you have to change, click on that. So cursor will point at that place, and then you can remove it, and here you can write 2. So this is the some shortcut. Okay, so we have like one more collection A2 and having a 10 and 20, and we have to check in the A1 A2 is available or not. So if you write here A2, so now I am passing here A2. If it is available all those element, it will print value is not available. Value is not available means 10 and 20. Let me give here 30 also. What is the method? First check. This is the containsAll method, so you have to use the containsAll, because containsAll we have to write here. And let me remove this one. Okay, so containsAll will check like inside the A1, which is 10, 20 or 30, A2 element is available or not, like 10 or 20. If it is available, it will return true. So let me run. You can see value is available. If you put here something like 28 and 20 is not available inside the A1, so what will happen? You can see value is not available. So exactly if this A2 value, A2 collections array list value will match all those value inside this A1, then only it will return true or false. Okay, so if it is all match true, if anyone is not matched and not available, it will return false, and based on that it will work. So this is the another method we have seen, containsAll. It is used to search the specified element in the collections. Iterator to array. Okay, so iterator, it means that it returns a iterator. So we have a one method called iterator. Okay, so for example, we have a some element. Okay, let me remove all those things. Okay, let me remove all those things and we can talk about the iterator. So for example, I have one array list and I have those data and I want to print it. So as of now, what I'm doing is I'm just writing here A1 and it's printing the data combinedly as a array form. But I don't want like that. I want 10, 20, 30 in the verticals. 10 here, 20 here, 30 here. Okay, how can I do it? So for that we have to iterate the array list. So for iterating the array list, we have a create the iterator. So how we can create A1 dot iterator? So we can create a iterator object with the help of this one, and we can store those iterator. Okay, once we store, we can use the for loop. Okay, and while using a for loop, we can iterate all those elements from here. So what we can write is, we can write iterator dot hash next. So it will give the next element. If it is true, if means element is available inside that hash next. What is this? Iterator dot hash next. Okay, this is the for, so we have to tick the while. In the while only we can put one condition, otherwise if you go with the for, you have to write 3 semicolons. You have, I hope you remember it. So we have to check this condition while iterator dot hash next, it will return the true. If it is returned true, we can print all those elements. How you can print all those elements from the iterator? So we can write iterator dot next. Iterator dot next will give the value. Okay, so what will happen? We have a one array list called A1. So we have created one iterator with the help of the iterator methods. And once iterator object is created, this all value is stored inside this iterator, 10, 20, 30 iterator. Now iterator having a capacity and having a capability to fetch one by one element from the array list. So it will iterate one by one element with the hash next method, and if it will check like first time 10, 20, 30, once it is reached to the next line, and next line is not available, so it will return false. Once it is false, it will go to the outside of while loop. But if iterator.hashNext will give true, it means element is available 10, 20, 30, it will go inside this, and through the iterator.next we can print those value. Okay, let me run. So if you run, you can see 10, 20, 30. So like that you can print with the help of the iterator. That is the things we have discussed as of now. Okay, so this is the use of iterator. It returns an iterator object. We can use the iterator methods. So public array object to array object to array. So we have a toArray method. It will return the object toArray. So it's convert collection into the array. So for example, we have a one collections and we have to convert. Let me remove these things. We have a one collections and we have to convert this collection in array. Right now it's a collection, but I want to convert in object array. So what I can do is I can write a1 dot toArray. We have a method called toArray. It will return the object type. So this will converted in array now, and now we can print those array. Okay, how we can print it? So for loop we can use let me remove these things, and based on the index we can print. Okay, so if you want to convert anything like collection to array, you can convert with the help of the toArray methods. Collection dot toArray, and you can print here ARRAY with the index value is I, and we can print all those elements. So this is the power of toArray. I hope you understood. Okay, so like that we can use the toArray method to convert collection into the array. So we have a one collection which is array list, and we have converted to the array. Okay, now we can see like toArray we have already seen. So it's convert collection into the array. Here the returns runtime type of the returned array is that the specified array. So it will specify the whatever the array you have given, it will return. We can discuss those later. Okay, and we have a empty method, is empty. So it's check if the collection is empty or not. So let me explain those also. For example, you have a one collection, and this collections means array list having a some value, and if I use a1 dot is empty method, so it will return true and false. Okay, is empty, and I will check with the one if conditions. Hey, if it is empty, you can print s out collection is empty. Collection is empty. If it is not, you can print collection having a value. Otherwise you can say collection is not empty. Collection is not empty. Okay, so right now in the collection having a value. Okay, so it will print collection is not empty, and if you remove this value, for example if you comment it will print collection is empty. Okay, let me run once. So you can see collection is empty. Why? Because right now there is no value inside the a1. So right now this collection is empty. So if you call a1 dot is empty, it will return true. Once it is true, it will print collection is empty. And if you have some value inside these collections, okay, what will happen? Okay, so if you see this, remove everything. if you see this, we have a 3 value right now. So if it is 3 value, it will check a1 dot is empty, so it will say no, it's not empty, so it will return false. So once it is false, it will go to the else condition and it will print the collection is not empty. Right? Understood? And this is the parallel stream, so we can discuss about the parallel stream in the Java 1.8 features, which is something like a stream API. We can discuss about it, parallel stream and a stream. It returned a possible parallel stream with the collection as it is source. We can discuss later. Okay, fine. This is the stream, so a stream also we can discuss in that place only, Java 1.8 features. It returns a sequential stream with the collection as it is source. This is the splitter, so it generates a splitter over the specified elements in the collection. You can use the splitter, it will split the value. Okay, and this is the equals method, so it's a match two collections, so it will check two collections are the same or not. Okay, this is the hash code, so we can generate a hash code of the particular object. It's return the hash code numbers of the collections. Okay, let me check once. For example, I have these collections and I have one more collections also. I need to check both are equals or not. So control, it means alt and point here, point here, point here, click on that only, and then I will change A2. Okay, and then after I will check both are equal or not. So I will remove this one and I will call one method called A1 is equal of A2 or not. So this one is also return me one boolean value. I will store this boolean value and I will put inside this if conditions and I will check collection is equal so I will click alt and here also I will click and I will write equal equal collection is equal, collection is not equal. Okay, let me run. If both are equal, it will print collection is equal. If I give here something else value 36, so right now both two collections are not equal, so it will print both collections are not equals. Why we are writing it? And one more things, I am doing work with array list. You can do the same things with the linked list, vector, stack. Okay, and this is the hash code. So if you want to print hash code of any particular object, for example, I want to print hash code of A2, so I will write A2 dot hash code method, hash code methods, and same thing I will print for A1 also. So I will write A1. Okay, and here I will give the 30 only, but both are different object and we can see what is the hash code value. So if you see both hash code value is same, 40051 40051. Let me change some value here. Okay, and let us print it. So if you print it, you can see something different is. This is 40051 40052. So this is the something hash code value we have generated for our collections. Okay, I hope you understood, guys. I am using the Java 70 JDK 70. Okay, and this we have discussed. So this is the method also clear, I think. Okay, let's go to the something hierarchy. So all the methods are completed which is useful and generally we are using as a real time in the industry, and we are utilizing those methods in the multiple times. So we have discussed those methods and based on those method only you can try to solve any of the problems, and we can get the solution definitely. So those methods are very useful, and generally or regularly we are using those method only. Okay, let's see the set hierarchy. So in the collections we have a list, set and queue. These are the three interface, and these three interface having a different collections. Let me open one. So here if you see in the collections having a list, so we have completed the list like array list, linked list, vector, stack, and we have discussed how to create a object and how to do the operations with this, and we have learned about the method also. Now we are going with the set. So in the set we can discuss about the hash set, linked list, link hash set, tree set, and those methods are very important. Okay, so now let's see the set hierarchy in Java. Okay, so for example, this is the iterable interface, this collection, and after the collection interface we can see the set interface. So iterable is a interface, collection is a interface. So in both, if it is both interface, we can extend it. If this one is a interface, this one is also interface, again extend it. If this is a interface and this is the classes, so we have to do implements. We have understood the OOPS concept. Okay, so based on that only this one is designed. So you can see here, this is the set interface, and set interface having some implemented classes, which is hash set, enum set, link hash set, and tree set, and those classes are very important. So let's talk about what is exactly set and how set is differentiate from the list. So if I talk about the list, so list is allowed to store the duplicate value, and it will also maintain the insertion order. But if you go with the set will not store the duplicate value, and it will not maintain the insertion order. This is the 2 points you have to remember while comparing a list and set. Okay, and if I talk about the hash set, enum set, link hash set, and tree set, in this all those classes having a different behavior, different working styles. Okay, so we can see those. So let's take the example of types of the set interface, or we can say implemented class of the set interface. So in Java, the set interface is a key interface in the collection framework that defines an unordered collection, means it will not maintain the insertion order. So this is the unordered collections of the unique element, and it will store the unique element value inside the set. If you store duplicate, it will not take. Okay, there are several subclasses of the set in Java. Set is interface, so set having a several implemented classes. Some of like hash set, link hash set, tree set. So we can discuss one by one, and what is the benefits and what are the behavior differences we have in these classes. We can discuss. So let's take the hash set. So this is the most commonly used implementations of the set interface. So like mostly we are using the set interface only, like hash set. And in Java it is used to hash table. It is used as a hash table to store its element, allowing for the constant time access and insertion. However, iteration order is not granted. Iteration order is not granted means whatever the order you have inserted the data, in the same order maybe you can't fetch it. Okay, so this is the things we have to remember it. So let's go with the set. So if I talk about the set interface, so we can say some point called set will store unique data. It will not allow duplicate. This is the first point. And it will not maintain the insertion order. It will not it will give insertion orders. It means that it's work on unordered order data. It will store unordered data. Okay, so this is the two things, and those behaviors will apply on the implemented classes also. Like has set is the same behavior like that only. Okay, so let's go to the here, and you can see like this is the most commonly used implementation of the set interface, has set in Java. It is used to hash table to store the element, allowing for the constant time access and insertion. However, iteration order is not guaranteed. Fine. So let's go to the here, and we can create one more class called set. Yeah, has set collection. Has set collections. So this is the some name we have given. Okay, let me change it. It's not looking good. Collections. Rename the file name has collections. Okay, let me create one method inside this. So I have created one method. Let me create one implemented classes. Because why I'm not creating an object for the set or list? Because those are the interface. So only we can create an object for the what? Implemented classes only. So that we can create an object, we can do the operations on that. So let it be create a set. So I will create a set as equal to new has set. Okay, has set. That is possible? Yeah, that is possible. No issue in that. Okay, so basically we need to import both files. So those are the available in the java.util.hasset and java.util.set. So this is the interface, and this is the parent of hasset. So set is capable to store the data of hasset, so that we can create a reference of hasset also. No issue. Okay, otherwise if you are not interested with the set, but generally we have to create a reference of the set only, so that we can achieve dynamic binding. Okay, dynamic binding. So here I have created the hasset one object, and I want to store some data into the hasset. So s.add, same method we can call, and we can add 10, and s.add 20. So I have added 20. s.add, I will add the 30. So this is the element I have added, and I will print it those element also. Okay, so we can print this also. So this is the way to create an object of the hasset. But we have learned like set will not store the duplicate element, and here if you see, I have inserted first 10, then 20, then 30, but it's printing 20, 10 and 30. So it means that it's not maintain the insertion order. Set will not mention the insertion order, maintain the insertion order, but list will maintain it. Here you can see the proof. Here you can see the proof. We have inserted 10, 20, 30, but it's printing the 20, 10, 30. So that we can say that this will not maintain the insertion order. One more things we have discussed, like this will not store the duplicate. So let me try to store some duplicate element. So I will try to add s.add, and I have already stored 10. Again I will try to store 10 element inside this. What will happen, we can see. So again already 10 is available, and one more 10 I will try to store it. So store duplicate element, store duplicate element. So I will try to store the duplicate element, which is 10. Let me see it will store or not. So here if you see, it will not store. So that is also confirmed. Like set has set, like set implemented classes will not store the duplicate element. So if already set having some data, you can't store again it. I hope you understood what I am saying. Okay, so this is the hash set. This is the behavior of hash set. It will not store the duplicate. It will not store duplicate element, and it's not added also. Okay, and we have discussed also one more point. It will not maintain the insertion order. So what about the order you have inserted the data? It will not maintain it. We have seen the proof. Okay, this is the hash set. Okay, so now we have added some data. Now I want to remove some data inside this. So I will call s dot remove methods, and having a removeAll, removeIf. So we can take this one, remove of some object. So I will give 20. So if I pass 20 here, it will remove the 20 element from this hash set. If you run this, you can see 20 will removed. Okay, so this is the things we have the same method like equals method, isEmpty, size methods. If you want to print a size, so same all those methods we can use here also, and we can take the help of those. So we can use the size, we can use the isEmpty, contains method also you can use. Okay, so this is the size of 2 only after removing the 20. Okay, that is fine. So we have created the hash set. Okay, and we have understood the behavior also. Same thing we can do with link hash set, but link hash set having some differences between the hash set and link hash set. So this is a subclasses of hash set. Okay, so linked hash set is a subclasses of hash set. It's maintain the order of insertion. It's maintain the insertion if it is element allowing for the predictable insertion iteration order. So that is something called link hash set will maintain the insertion order if you take the link hash set. So let me do one thing. We have created the object of let me do one thing. So let me comment it out. Okay, comment, and we have a 3 value. So what I'm doing is like I'm going to write here hash set. Okay, link hash set, LIN linked hash set. Okay, so hash set I will convert it with the link hash set, and we can see the insertion order it will maintain or not. Let me remove this value. Okay, so we have converted the link hash set. Let me run. So if you see, it will maintain the insertion orders. So we can, the differences between the hash set and link hash set is hash set will not maintain the insertion order, but link hash set will maintain the insertion order. You can see, and you have a proof in front of you. Okay, right. Okay, right. Let me go to the slide, and you can see here it's saying same thing. It's like it's a subclass. It maintain the order of insertion of the elements, so it will maintain the insertion orders. Okay, we have one more class is called tree set. So this is a implementations of the set interface that use a red black tree. So if you are going with the some data structure concept, so I hope you know the red black tree. Okay, so in the tree also having a different types of the tree. Sorry. So this is the implementation of the red black tree. So this is the implementation of the set interface, and it's also use a red black tree internally to store its element. It's maintain element in sorted order. So whatever the value you have stored inside this tree set, it will store the data in the sorted order, allowing for the efficient range, query and other operation that require sorted data. So internally it's a behavior like it will not store a duplicate, and it will internally sort your element also. Let's go and do the operations and try to understand. So for example, I will remove this one. So control, okay, and let me remove and write tree set and control shift O, so it will import it. Okay, and we have added the three data. Okay, and let me add some of the data here, and which is nothing but something like that, something big element. Here also I will write something, add something like 200 or 400 we can give. And if you print it, it will print the data in sorted orders. Even if you have not entered the data in the sorted order, it will print in the sorted orders. Why? Because a tree set internally maintain what? Sorting. So let me go to the notepad. So here we have a like hash set. Okay, linked hash set, and we have a tree set. So as of now we have discussed like hash set will not maintain insertion order. Orders. Link hash set maintain insertion orders, and sort the element. So whenever you want to sort the element while storing time only, you can take the help of the tree set. But if you want to maintain the insertion order, go with the link hash set. And if you don't want to maintain any insertion order, you just want to store the data, then you can go with the hash set. So these are the things you have to aware about it, and then only you can do work on that. Okay, so I hope it's clear as of now what are the implemented classes and how we are using those. Okay, each of these sets of classes provide the different performance characteristics and it is optimized for the different use case. By using the appropriate set implementation, developers can improve the performance and scalability of their Java applications. So we can take any of these, but based on the requirement only, and we have understand the requirement. Like if you want this one, you can go with that one. If you want a sorted order, go with the tree set. So that time you can get good performance, and also you can say like you can get a good time complexity and everything. Okay, Understood? And this is the queue hierarchy in Java. So if I talk about the queue, so queue is also one of the collections part only, but you have, I think, know about the stack. So in the previous section, list implemented classes, we have seen the stack. In the opposite of a stack, we can see the queue hierarchy in Java. So queue is also very popular, okay, and queue will store the data like first in first out. In this manner, the people will, the value which you have inserted first, it will remove first. But in the stack, we have seen like the value will be insert first, it will remove last. So those are the differences we have to understand. Okay, so those are the collections hierarchy. So this is also part of the collections, and this is the queue is a interface, and implemented classes of the queue is linked list, priority queue, and array dequeue. Okay, so those are the queue, and these are the very important, so we can discuss one by one. Okay, these are the types of the queue, and this is the iterators, how it will work. So those part we can cover in the next video, how priority queue and dequeue work. Already we have discussed the linked list. Okay, so no need to discuss again. We can go with the priority queue and array dequeue. Okay, and we can implement it. We can write some coding questions also in that, and we can try to understand what is the exactly difference between the priority queue and array dequeue. Okay, thank you so much.